Hi everyone. In today's challenge, we have a problem. The problem name is construct binary tree from Inorder and Postorder Traversal. Alright, and the problem number is 106. Right. So guys, first of all, we are going to clearly understand what this problem says, what we have to do in this problem. After that, we are going to move to the logic part. We are going to see how we can solve this particular problem, and after that, we are going to do implementation part. We are going to implement our logic in C++, Java, and Python programming language. Fine. Now let's see what this problem says. Given a two integer arrays, inorders and postorders, where inorder is the inorder traversal of a binary tree and postorder is the postorder traversal of a same tree. Construct and return the binary tree. So guys, it says that we are given the two things. First thing is inorder array, second thing is postorder array. And inorder, what inorder contain? This array contain the inorder traversal of a binary tree, and we don't know what is a binary tree right now, right? And postorder array, let me write a postorder. This contains the order of a postorder of a binary tree, right? So if you focus on example 1, then you can see there is a binary tree 3, 9, then we have a 9, then we have 20, and on 20 we have 15 and 7, right? So what is the post order for this? If you don't know about pre-order, post order, and in order, so let me tell you first of all, just focus this thing pre-order. So pre-order is nothing but first of all you are going to take a root, then left side, then right side, means right node, left node and right node, right? But for post in order, after that it come in order, which gonna says that first of all take a left side, left part, then root, then right part. And the post order says that I hope you got it. Post order is gonna take first of all we can say left part, second after that take the right part, and then you have to come to the root. So this is nothing but pre-order, in order, post order traversal, right? So what will be the in order for this particular tree? You can see that first of all in order we take left part. So for 3 we are going to take 9. So it's going to be 9. You can see that. And after that what we are going to do, we are going to take the root. So there is a no left part of 9. So we are not going to move ahead. But after that we are going to take root. That is nothing but 3. Right? And then we are going to move to the right side. And right side we have 20. But itself it is a root. So it's going to take the left part of that. That is nothing but 15. Then we come to the root 20 and then we come to 7. And if you focus over the example as well, we are given this thing only 9, 3, 15, 20 and 7, right? So let me put comma here. And the post order is similarly we can calculate, that is nothing but 9, 15, 7, 20 and 3, which we don't need to calculate it because it is already given to us. But we need to make a tree from by using these two array in order to post order traversals, right? Now how we can do this? This is our logic part. But first of all, you should clear this problem that we are given the two things in order traversal, post order traversal, and we have to make our tree, or we can say binary tree, by using this inorder and postorder traversal, right? So let's move to the logic part and see how we can implement these things, right? How we can solve this particular problem. So let's write here logic part, and what I'm going to do is nothing but I'm going to use the concept of inorder and postorder. Inorder says that first of all we are going to take left side, then right side, then root, not left side, root and right side, right? And postorder says that first of all we are going to take a left side, then right, then root. So can we use this concept? Because if we know root is at the end of the post order, whatever the data at the end is going to be root, right? Because first of all, you're going to traverse the left side, then right side, then it come to root. So one thing is clear that whatever the end of the post order is nothing but going to be my root, isn't it? Because root is coming at the end, right? So whatever at the end of the post order, that is my root. So I can say for now I have got it my root. Now what will be on the left side and what node will be on the right side of this three? That is the problem, right? So that thing is going to tell us by the in-order thing. So just we need to find where 3 is present in order, because in order says that left side is going to be first, then right root, then right side, right? So we can find 3 only in order, and we come to know that 3 is here. So what we can do? We can say from 3, whatever the node present on the 3 left, that is nothing but going to be the left of 3. Whatever the node present after the 3, that is going to be the right of 3. So that is clear by the in order. So we know that there is only one node 9, right? So there's a one node and right. So what could we do? We can just take this color and we can say left is nothing but going to be 9, right? And after on the right side, there are 3 nodes. Now, what will be the root node? What will be the left of that particular node? And what will be the right node? That also we're going to tell by this in order and post order only. So how? Let's see that. Now let's understand with the core parts. So I'm going to give the index. So let me take this array here, and this array is going to be like this. So this is in order 9, 3, 15, 20 and 7, right? All right, so this is going to be main core part. So you need to focus over here. This is 0 index, 1 index, 2 index, 3 index and 4 index. Fine. And same goes for post order. So let me take it quickly post order as well. So 9, 15, 7, 20 and 3, right? And let me also take it the index. So guys, now you can focus over here. First of all, what will be the root? Whatever at the end of the post order, right? So we can see it is a 3. So we have written 3 as a root. Now the left side of this, how many, what is the left side, right? What is the left part of this three node? So that will be tell by node. So first of all, what we are going to do, we are going to find the index where it actually present, right? So we find out that at one index we have a three node. So 0 to 1 is going to be the left part of 3, and not 0 to 1, actually 0 to 0, because 1 has already been taken 3, and we can say 2 to 4 is going to be right part of our 3. So that is clear, right? So you can also observe in a binary tree, if you are not getting these, you can see on the 3 left side of 3 we have 9 which come in 0 to 0, and on the right side of 3 we have 20, 15 and 7 which come in 2 to 4 index, right? So that is clear for 3 part. Now let's move to the left side, right? So for left side, what I can say there, so in we can say starting we have this search space, right? 0 to 4 we have this array post order, but for left side what will be the one post order? So I could say my post order will be nothing but this one. And how would I find out that this is my post order for left side? So as for finding that, just you need to focus over on this particular one. We have a 0 and 0 of in order left side, right? So 0 to 0, right? So now we need to find how many indexes are there. How we are getting it? So there is only 0. We can say the 0 part is there. Means I want to say that there is only one index, means one element, or we can say one node on the left side. Just we have find out, and we are going to add in the post order starts. So we're going to add 0, whatever the starting of 0, 0 plus how many add with 0. So we're going to say nothing but 0. So my post order is going to be 0 plus 0, that is 0 index. So post order is going to be this thing for a left side of 3, and that is going to be nothing but 9 only. So there is only one element. So the last element also this. So this is going to be root, and the left side of this. So I could say that left side of 9 is going to be, first of all, find out 9 where exists in this in order. Now you could focus that 9 exists at 0, right? So left side is going to be nothing but minus 1, minus 1 to minus, or we can say whatever the at the end. So there is no we can say minus 1 exit, we are at the boundary of that in order traversal. So there is no left node. Is there any right node? So you can see that our boundary was this, and we got a 0 only. So there is also no right node, right? If we are at 9 and our in order is nothing but this 9 only, right? So if in order is this only for us and post is also this, so this is a root node, we got it. And after that we could say that there is no left node present on the left side, no node present on the right side. So there is going to be no node, so it's going to be just a leaf node. But if you focus on the right part, now we can say for right part, what would be the right part as? What would be the right part? Right part is going to be nothing but just we have to decrement the one side. So that is going to be nothing but 20, right? So we can say now our post order is nothing but, let me move this logic part, and post order is nothing but it's we can say 9, 15, 7 and 20, right? And the not 9, it's going to be 15, fine. And what it could be, and in order sides, whatever at the end of element, that is going to be root. So I made it a root, so which is nothing but 20, fine. And the left side is going to be just, you have to find out from in order traversal. So in order our was 2 to 4, earlier it was 2 to 4, this one. Here you have to find 20. 20 is at third index, right? So whatever the left part of 20, so it was 0 to 2, and in order we got at one index, third index, right? It was 2 to 4, and in order we got at third index. So we can say 2 to whatever 3 minus 1, 2, and 3 plus 1, that is 4. 4 to 4 is going to be right part. So 2 to 2 is nothing but only one element, that we can write 50, and 4 to 4 is 7, so we can write 7. And I know it is going to be very complex if you will try to find out in first time, but let me summarize this particular part, just what we are doing. So let me take it later here. So all right, so what we were doing, we are first of all finding, we know that the post order last element at the post order traversal is going to be the root. So we are going to take that 3, and we are going to find the that particular element from in order, and find out the index, what is that index where that particular element exists. So we could come to know that 3 exists at the index 1, right? So what we have done, we have to make a new array, or we have told them that whatever at the 3 index left side is going to be left part. So there is only n9, whatever on the right side, that is going to be the right part. So we come to know that 3 is going to have left part containing this one node only, and right part containing this 3 node, fine. So now if we will move to the left part, and there we come to know that the only part, so we don't need to take care about this, because preorder is nothing but 9 and in order is also 9, right? So we can say this is going to be root, and there is no left part, right part, so just make it root. But for right side we have 3 node, right? So we're going to say for 3 node, what was our preorder? Preorder was 50, 7, 20 and 3, and in order was our, we could say 15, 20, not, it will not be 3 because we have already taken 3, 15, 20 and 7, right? So this was in order. So we can say that whatever that this is post order, this is our in order. So whatever at the end of the post order is going to be root. So we could say on the right side you can see 20, so we make 20 as a root. So we make 20 as a root, right? And once we make a 20 as a root, now we know that the whatever find out the 20 on in order traversals, and we come to know that this is a third index. So whatever element on the left side of 20, that is only 15, you can see that, and on the right side that is only 7. So this is going to be left side of 20 is going to be 15 and right side is going to be 7, right? And after that, once we are done this, we have completely we can say come out of bound, because once you will find out 15, there is you can see that you will try to find out 15 here on inorders, and in order you can say that this is a 2 only, right? So there is no boundary. I hope you get it. There is a no boundary because we have already taken 9, 3, 20 and 7, and for 15 we find out that your index was 2 to 2, and once you have taken 2 as a 15, so you will say whatever the element on the left side, but there is only one element 15. So if you find say the 15 I have taken, whatever element on the left side is going to be left part of 15, whatever element on the right side is going to be right part of 15, but there is no left part, no right part, right? So there is no element exist, so it's going to be null. So it is also going to be null, it is also going to be null, right? So this is also going to be null, same, and this is also going to be null. So this is how we are going to do. We are going to just take the help of indexes. We are going to use a dictionary which will tell us that where that particular element exists. After that, we are going to divide our left side and right side by just that particular index. So I know it's quite complex, but when you see the code, when you will go to the through the code, then definitely you will have a better idea. So let's move to the code part and see how we can implement this particular logic in C++, Java, and Python programming language. And I hope, guys, if you still have no doubt, no, we can say no understanding of this particular logic, definitely by the code you will have a better understanding. So let's move to the code part. So guys, first of all, let me take a note Java. First of all, let me take Python, and let me increase the size. Right. So what I'm going to do, first of all, I'm going to make a dictionary. So I could say dictionary, which is initially empty. I'm going to traverse over my Inorder array for I in range of. Let me find the index length of my Inorder, and you know that Inorder also contains a traversal of binary and Postorder also, right? But both are going to be have same number of nodes, isn't it? So I could take a one time only. So I can say for I in range of n, I can say that in order of I is going to be nothing but I. So I maintain the value. I keep the key as a value, whatever the value in order, and value as an index of that particular in order array, right? So you will see that 9 is stand at 0, so I will make 9 as a key and 0 as a value. Fine. Once we are done these things, what we are going to do, we are going to traverse, or we are going to use a function. I give a function, nested function solve, or let make it a get tree. Fine. And here what I'm going to do, I'm going to take starting of in order. So starting in order, and we can say and in order, and then we can say start post preorder, not preorder, post order, and end preorder, post order. Fine. So let me make it in this. Fine. One base can we can say the base condition is going to be nothing but start order in order is out of bound, right? If it is greater than in and in order, so we can say this is a base condition. Just return it. But there is also one more base condition, that is start post order also should not be the out of bound, right? So end post order. So we could say return none. So there is going to be no node, right? All right. So once this is done, we are going to say nothing but we are going to find out the first of all that particular node. We are going to create a last post order is going to create a node. So we're going to say whatever the index value at the end of the post order. So just that is going to be nothing but our node, right? So we're going to say tree node of post order. So I could say post order, and here I going to pass the last, right? So I can say end of post order, whatever the index at end the post order. So that would be my node, and the left side of this is going to be the in order's left side, and right side will be going to be the in order right side. So let me find out the index of in order. I could say current index is going to be nothing but in order of that particular, right? So in order, I could not find by using the index, right? I don't know where it is present. So I can use my dictionary which I have created. I can say dictionary of, that particular value. So I can say just I need to take this particular value. This particular value is going to give me the we can say the index where that particular element present in our in order array, right? So once we are done this thing, we are going to know that this current index. So we are going to call the left side of node is going to be nothing but get tree, and start in order, because this is going to be left side. So start order will remain same, but end in order is going to decrement by 1, right? Okay, and start post order is going to be remain same, right? But we can say end post order is going to be changes. It's going to be start post order. We can say add our current index, whatever the current index is there, and subtract your start things of your in order things. And we have already seen why, because we need to find out the current post order now for this particular left part, and we are going to decrement by 1. Why we are decrementing by 1? Because we have already taken the last element, right? So we have already taken this particular 3, so we are going to decrement by 1. But note right side is going to be same, get tree start in order, note start in order. Here you have to move to the right side, so right side is going to be current index and plus 1, and here note and in order it should be current index minus 1, right? So current index plus 1 comma, and in order will remain same here, and start post order is going to change here start post order is not going to remain same. It's going to be changed. That is going to be nothing but we can say start post order and current index minus start in order, right? And is here we are not going to decrement by one because we are not take we have already taken that particular parts, so we are no need to decrement the minus one because we are moving from that particular part to right part. If I have to tell in detail, then you can see an example. If we are finding a 3 rate, so we are going to say this is should be the right we can say in order part, but here this should be our the right part, right? I hope you are getting this. So we are going to getting a 15, 7 and 20. So this is going to be nothing but our starting. We are going to start from one index. And what we are going to do till we are going to go end post order minus 1. So here we have to decrement it because we have already taken 3 part, right? So every time we have to decrement by end post order things, means last index, because we have already taken that particular index for a root. So once we are done these things, we are going to return our node. So let's call this function. So I'm going to say get re, all right, and I'm going to pass starting the zeros and minus 1, 0 and minus 1, right? So as same they have same length. Now let's return our whatever this is going to be written, right? So let's run this code and see whether it's working fine or we are getting any error or not. So let me see. So we got an error that is nothing but end post order. So end post order should be there. All right, so I have to write RA. Let me see any other error. Yeah, there is one more error that is nothing but start in order, right? Start in order is not there. So they have done something start post order in order. They should be in order, right? So yeah, very we could say that variable mistakes and that happen when you are trying to do a first time, right? So that's you can see that both the test cases are passed. So let's try to submit this code and see whether we are getting a right output or not. All right, so and you can see that guys we have already we have successfully submitted this particular we can see the implementation of pythons. And I hope guys you understood the python logic. If you still have any kind of doubt, you can ask in the comment section. Guys, due to some issue I could not able to solve with the C++ or Java, but I hope guys you understood the logic part and you understood this Python logic. If you still have any kind of doubt, you can write in the comment section. And definitely if you understood the logic part, you can implement in your programming language also. So I believe guys you will implement in your C++ or Java or any other programming language which you like. So guys, if you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.